everyone to Data Science and Technologies. This afternoon we have Dr. Phil Williams, and he is going to be giving you an introduction to Internet of Things and giving also some demonstrations. So you can see a little bit on the hands-on side of how an IoT system might work, starting with the basics. So, Dr. Williams, I will turn it over to you.
Thank you, Dr. Pierce. Some of the things that I'll be showing you today are quite a bit about signals. And I thought signals didn't quite fully capture what I'm going to talk about, so I thought I'd add to my, see, I've got to be on the correct screen. Here we go. And okay, just want to check my microphone. So a little slow to start up. So I decided I would add to my title and call this Drones, Phones, Raspberry Pi Dashboard, the Mad Scientist, and the Secret Agent.
Oh, that's catchy.
And we'll be talking about drones, of course, and phones and these others. So let's see if I can advance my slide. Yes. I wanted to start out with some definitions. What is IoT? So IoT is the Internet of Things. And it's about the network of physical devices, vehicles, appliances, all those kinds of things that we now have that connect to the Internet. Also, for some of these physical devices, such as thermostats, wearable fitness trackers, or even industrial machinery. So we're talking about things that are the very smallest to full-size industrial machines. All these different things now connected to the network. And what I encourage you to do is to continue to study data science, and including IoT and even possibly bioinformatics, because we do see that the pay is fairly substantial for some of these areas. Also, to continue for some of the definitions, I wanted to ask the AI, what is a MAC address? So the MAC address means Media Access Control. And it's a unique 12-digit hexadecimal number. And what this does, it's required to access the Internet in terms of getting an IP address. To get an IP address, you must first have a MAC address, and then you request an IP address, and that gets you connected to the network. Also, in some cases, there is what we call a random MAC address. And these are for situations where you don't want to be tracked by your MAC address. And this is very typical for the phones nowadays, where they're actually going to display a randomized MAC address rather than actually your true MAC address. My phone may talk to me at some point here. That's part of the Internet of Things. So what I'm doing is I'm tracking. That was the temperature of the server. Previously, it talked about the load on the server. I'll go ahead and shut that off for now so that we don't have to listen to that again. But what it demonstrates is that my phone is just one of many Internet of Things devices. So I'll go ahead and silence that since we've already heard that part of it. Let me just find where that part is at and silence that real quickly. Okay. There. Okay, so I've silenced that. You won't have to listen to that. But it demonstrates that there are so many different kinds of Internet of Things devices, including telephones, servers, and even some of the small hardware that I'll demonstrate to you here in just a little bit. So one of the questions I had, and you're welcome to turn on your microphone and answer this. Notice my question here is, how many MAC addresses does your phone have? Would anyone like to talk about how many MAC addresses their phone has?
Oh, that's a good question.
Do we have our speakers on?
Yes, we do have speakers on.
Good, okay. Anyone listening that would like to answer that question? How many MAC addresses does your phone have?
I'm assuming it has at least one.
Yes, so we're starting off with one. So we're starting with one. Would anyone like to say which one that is for that MAC address? Your phone is a cellular device? Oh, here we go. Okay. So here, someone suggested if it's randomized, then it could be infinite. So really, I'm not talking about the randomized MAC address. I'm really talking about the real hardware MAC address. But you're on the right track here. I am talking about two different things, the randomized address and the real address. So what you've got here, you've got at least, let's start out with one. One is your cellular network. So let's go on from there. What else do we have for a MAC address besides your cellular network?
Oh, how about Wi-Fi?
Wi-Fi, we're into two MAC addresses now. Good, so we've got at least two. And
Bluetooth?
there you go, that's the one I'm looking for, yes. The Bluetooth, thank you very much. We now have all three MAC addresses on your phone.
And do you use this, if you have multiple Wi-Fis, is it the same MAC address from Wi-Fi to Wi-Fi, or does each Wi-Fi generate a unique?
So what's happening here, as I understand the randomization, you've got an actual MAC address for the hardware, but what you're doing is you're transmitting a random MAC address for these networks to see. And so they can say, yes, here's a network here, and if you have the credentials, you can attach to that. But if you walk down the street, they're not able to track you by a static, the actual true MAC address. So you don't transmit the true MAC address until you attach to a network.
Okay.
And then that network may actually take on your real MAC address.
Okay.
But when you disconnect and walk away, they can't really track you.
Okay.
So this is all kinds of important things that have to do with privacy with your phone. Now we're getting to the serious business of drones. And what we see here is a discussion of the military use of drones. We have intelligence, surveillance, and reconnaissance going on with these fairly inexpensive drones. So we have enhanced visibility. And when they fly up high in the air and have cameras, we now have the ability to gather actionable intelligence. And also there's persistent monitoring. So imagine you've got a situation where you have two or more drones. You could put these drones up in the air. They've got cameras. They can provide you a view of the situation. And so it gives you essentially the situational surveillance here. And if the battery goes down on one, you've got the others. You can charge up the one that's down, relaunch it, bring the others back, recharge those. So you can have essentially some ability to loiter in an area and give you continuous surveillance, which then enhances operational safety and helps with decision making. So these drones are quite important in terms of military usage. And of course, here we have something that's fairly current, the Russian invasion of Ukraine. And both sides used drones. And they used them not only for reconnaissance, but also for bombing attacks. And I actually looked this up once and saw a video. I was very surprised at the level, the size of the payload that they were actually able to lift. It's a fairly substantial bomb that these things can carry. So that's very concerning that such a small, inexpensive device can carry such a significant payload. And of course, here's something that's pretty relevant in the news. This one is January 17th of this year. Latest Chinese drone update could cause chaos across the US. And here's why. So the drone maker DJI announced a software update. And what it's doing is it's taking the guardrails off of the drone. So from January 13th onward, the geofencing function that prevented the drones from flying in restricted areas is now no longer effective. So here before, they couldn't fly in certain areas. Now they can fly anywhere they want. That's a bit of a concern.
And actually, there's a lot of folks who are having to drop the DJI drones because of the fact it has a Chinese manufacturer.
Yes. And so here we are, US weighs ban on Chinese drones. citing national security concerns. Absolutely. So you see that drones are very much in the news lately, and a very critical kind of thing that we need to be aware of. So now I'm going to shift gears, and I'm going to introduce to you some of the hardware that I use to document drones in my neighborhood. So here we have the Raspberry Pi hardware family. Notice that we've got the Raspberry Pi 0WH. The W is for Wi-Fi, and the H is for headers. That means that you can buy it with the headers already soldered on. So that's convenient if you want to attach peripherals. It's better to have them already soldered on rather than try to solder them yourself if you're not very good at soldering. But if you're only interested in the Wi-Fi part, you don't necessarily need the headers on there. I want to also bring your attention to this part right here. This is where the SD card slot, the SD card will go into the slot right here, and that will hold the operating system. Notice also it has a camera port. So you can actually attach a camera to this. So it has Wi-Fi, an operating system, and a camera port. Now we get to the Raspberry Pi 5. We don't see the SD card slot, it's underneath, but again, it carries the operating system. And notice also it has 2 camera ports. And I actually have a project where I'm using both ports, and we may see the data coming from that later on. So the first 2 are microcomputers with an operating system. The newest one is the Raspberry Pi Pico, and it is a little different. It's a microcontroller. So let's talk about the operating system for these. This is a phylogenetic tree. I work in bioinformatics. In bioinformatics, we often like to look at things in terms of their evolutionary origins. Everything comes from somewhere, whether it be living things or cars or operating systems. So here is the source of where these operating systems come from. Do we have any Linux users in the audience? Feel free to speak up or put it in the chat. Linux users, anyone? What about Android users? Anyone use Android? Okay, if you're an Android user, you're a Linux user. Android uses the Linux OS. Mac users, anyone? That's Linux as well. And what about Ubuntu? Anyone using Ubuntu or any other Linux operating system that you see on the screen here? Anyone? So Ubuntu has been around for quite a number of years. I like to describe Ubuntu as the sophisticated older brother in Linux. Whereas the Raspberry Pi OS is more like the younger brother. Is there something coming on in the chat? No, it's not? Okay, just want to check. All right. So the Raspberry Pi is like the feisty younger brother that goes out in the world and does some really interesting things. That's for the Raspberry Pi. And also then Kali is like the secret agent, the little brother as well. Do we have any Kali users in the audience? And I have a link down below in the slides, and you should get a copy of the slides later on. And so it's a much more in-depth phylogenetic tree. It's huge, and it shows quite a bit of where Linux comes from and where it's going in terms of different operating systems. And what I've done is I've actually installed Kali Linux on a USB drive, and I've used that one in the past to do some cybersecurity testing. But also, there's a pre-built version for the Raspberry Pi. And here are some instructions of how to install that for use on a Raspberry Pi in terms of putting it on the SD card and using that. Yeah, and so here's someone that actually uses Kali with their cybersecurity students. Yes, Kali is very much the cybersecurity side of the Linux operating system. And for me, the more I looked at the Raspberry Pi, the more interesting cybersecurity things I found. And that's how I became aware of cybersecurity, was through the Raspberry Pi. And it's a good thing I did too. There are some really interesting things going on in cybersecurity nowadays. And here is the hardware that I use for my drone detection. You see, this is an older version of the Raspberry Pi here, but I like this picture. It's a really cool looking tech device here in this plastic case. Also, notice that I've got the hardware, an alpha wireless USB adapter, and that is used for to put in monitor mode, so I can then collect data through Wi-Fi. And notice I have the omnidirectional antenna here, which I use more recently. I'm starting to use the omnidirectional antenna for collecting this kind of data. But in the past, and I continue to use the Yagi directional antennas. I live in a fairly large apartment complex, and it's an absolute playground for Wi-Fi signals. And so you can see that I use this aluminum Yagi antenna to kind of reach more distance. And what happens with the Yagi antennas is while you get more distance out front, it really reduces your side coverage and your behind coverage. So this is why I realize now that I like to use both a directional antenna and an omnidirectional antenna to collect data, both around me in this bubble versus out at a distance. And notice also PCB antennas, printed circuit board antennas that I've got here. I've got both of these, and I've used these in the past as well. Now we'll shift from the microcomputers to the microcontrollers. Whereas the microcomputers have an operating system like Linux, the microcontrollers are a little different. There's not an operating system involved in these. But notice the inexpensive price of these. Raspberry Pi Pico W, $6. And notice the ESP32C3, essentially a $5 device. And I've got an example right here. So here is an example of the ESP32C. Look, that's essentially a $5 device.
Right. Do you want to switch to camera mode so they can see it online?
Yeah, go ahead and put it on the camera mode so they can see that one. Thank you.
Yeah, let me go ahead. What I can do here is, let's just do a quick switch to share camera. All right.
Let me just bring it over here so they can kind of see it.
Yeah.
All right. Yeah, so look how small this is. So here we have the ESP32C3. Let me also bring on the Raspberry Pi Pico. Here we have the Pico with the headers soldered on versus without the headers. If you're just using it for Wi-Fi and you don't need peripherals, you don't need headers. And so it's very lightweight, very convenient to use. Okay, thank you. We'll just leave that view there, and we'll come back and do a demo later, but I just wanted to introduce you to some of the hardware that I'm talking about currently. Thank you. And of course, there's also the ESP32 dev kit. It's a little bit more expensive. It's way up there to $8, but it's just fascinating, the capabilities for such inexpensive hardware. So the question, what methods can we use to program these? Let me get on the right screen and I'll be able to, okay, there we go, good. And so here's what we've got. We have choices. It's so nice to have choices. Look at the choices we have for programming the microcontrollers. And they're a little different, whereas the microcomputers have an operating system. Here we've got a bootloader. And so we've got different bootloaders to load up different kinds of code. Notice the first thing I've got here is C code. While the Arduino IDE is not a bootloader, I've added it here just to demonstrate that in order to write the code, you may use an IDE, and then you would compile that code and you would download that to the board. And once it's in the board, then the bootloader can see that code, and when you power up the unit, it will read that into memory and execute that code. So we've started out first with programming in C, but we also very conveniently have MicroPython and CircuitPython. Do we have any Python programmers in the audience?
We do a lot. We've been doing a lot with Python.
Great, glad to hear that. Okay. So here is the question then. Is Python named for the snake Python or for Monty Python? Anyone know the answer to that one?
Ooh. Okay. I'm a big Monty Python fan.
There you go. Well, you've got it right. It's Monty Python. Apparently, programmers have a sense of humor,
Yeah.
and it's named for Monty Python. But notice that, of course, they have the snake's logo to go with that. So it's very nice to have 3 different methods, at least 2 different Python and 1 in C to program these very inexpensive microcontrollers. Now for the IDEs, Thani is the one that I use, and there's also PyCharm. I've not used that one. And there are other methods as well, other IDEs and other methods that don't even include an IDE, just very crude kinds of methods. You could write Python code and you could just download it to the board. For the CircuitPython, think of that like a little USB drive. It's got USB storage on it. So if you store some code on there, and if the code is called code.py, and you then power up the unit, the bootloader will then load up the Python interpreter, and that Python interpreter will then load into memory that script and execute that script. So it's a very comfortable and easy way to get started with microcontrollers. I'm very pleased to have these kinds of choices. And I have a GitHub where you can download some very simple Python scripts to get you started with CircuitPython. And I use these for workshops. Now, we're coming back to the drones. So now that you've seen some of the hardware that I'm using, we can come back and talk about drones. I've collected over 40 unique drone IDs so far. And the methods, of course, that I've used to collect these are various, including Python script on the Pico, C code on the ESP32, and also AeroDump-ng using the Linux operating system. 3 different ways to collect drone IDs. We talked about the MAC address, and one of the questions I had was, when I see these IDs and I didn't know what it was, my question was, what am I looking at here? So I took the MAC address and plugged it into this little page, which is essentially the MAC to vendor. And we see now the vendor is DJI. And if we then plug in that string into the search engine, we see that this is the manufacturer of the drones. So went from not knowing what I was seeing to taking the MAC address and finding out the manufacturer, and then finding out what the manufacturer actually manufactures, and it is drones. So I also use AirCrack-ng and that's a suite of software used to, it's essentially for packet sniffing. This is Wi-Fi. Wi-Fi is free to capture, it's radio waves. Anyone with hardware and software can go ahead and pick up these radio waves, and we can then try to understand what it is we're looking at. So here are the capabilities of AeroDump-ng. A view Wi-Fi network status, including open or encrypted, and we'll see some data that demonstrates whether it's open or encrypted or not, at least maybe for the open part. And also, you can use it to passively capture encrypted PSK. The PSK is the pre-shared key for Wi-Fi. That's the key that's on the side of your Wi-Fi unit in your home, the one that you want to put into your devices at home, but keep anyone else outside of your home from knowing what that is. So it's a pre-shared key or a PSK. Generically, people will call it a password, but it's really not a password. It's a pre-shared key for Wi-Fi. So also with this type of software, you can see the MAC address of the hardware on the networks. You can not only see the MAC address of the access point, but you can see the MAC address of the things that are connecting to that access point. So it's quite a bit of fascinating data that you can collect with the hardware and software that I'm showing you. Also, another thing that I've noticed, and I don't have a good slide for that, but you can sort of visualize maybe what I'm talking about. Crowdsourced population density change estimates. I started seeing particular kinds of data, and I just didn't really know what I was seeing. I've looked at it for years. I could see the MAC address, and I knew that the MAC address belonged to an Apple product. But what was going on with this particular Apple product was quite unique. It seemed to be sort of leaking some of the things that were attaching to it. And the only things that it would leak were randomized MAC addresses. So you didn't really know what was being attached to it, but you could see how often. So that was an interesting crowdsourcing experiment that we may continue to look at. But here is the perfect example of some of the data that I collect with this method. Notice the first thing is the BSSID, and that is the MAC address. We move along then to first time seen. So here is the date stamp, and you can see that this is just a couple of days ago. So it's a fairly fresh bit of data that I wanted to share with you. The first time seen. Notice also the last time seen. And what we can do here is we can then determine how long it's been around. In this case, of course, it's been around for quite some time in terms of when I put this data into a slide. What it tells you is first time seen and last time seen. It doesn't tell you how many times it came or went. So you don't know if it was continuously here, first time, last time, or if it came and went several times, and this was just the first time seen and the last time seen. So there are really sort of we don't know completely what's going on with that particular bit of data, but we sort of have a basic idea of what's happening. That brings us to the channel. We can see that this particular device is on channel 1 for Wi-Fi. We also have the speed, and I've not done much looking at speed, but there might be some interesting things now that I think about it to do with speed. What are the differences in speed for different hardware? So that could be interesting to look at. Continuing on, we have privacy. And notice for this particular device, it's open. And notice for cipher, it's an empty string. It's open. There is no cipher here. Authentication. There is no authentication here because it's an open network. That brings us to power, minus 72. It's quite often where we see them showing power in a negative number. And what this means is the more negative it is, the lower your power, and this could indicate that it's further away, and this is why the power is so much lower. So the closer you get to 0, likely the higher the power, and the closer the device is to you. Notice also the ESSID, and see what this device is. It's a RoboVac. It's a robotic vacuum cleaner. And it's my robotic vacuum cleaner, and this is why the power is fairly substantial here. And typically, notice I've got instructions here where you may then ideally bring this home, set it up. It's an open network. You would ideally take your phone, attach to this open network, and maybe open up some kind of a web page where you're supposed to put in your passkey for your own Wi-Fi network, and then reset the device. It will reset. This open network will go away because it's now attached to your home Wi-Fi. And then you can do all those Internet of Things stuff that you might want to do with your vacuum cleaner. This vacuum cleaner has a nice remote to it. And with the remote, I can put it in auto mode and go to work, and it vacuums the floor. When I come back, it's parked in its charger, it's charged up, ready to go again. I have no intention of putting this on my home network. I like it just where it is as a positive control to show me what an open network looks like and what the power is on a network, open network that is close to where I am. So I'm going to keep it just like this. And interestingly enough, I was exercising one day on doing floor exercises right next to my robotic vacuum cleaner, and it came out of its charging bay and started coming towards me. So I jumped up and picked up my remote and pressed the button to have it return to its charger, which then brings us to the questions of, did someone get into that? And did they launch my vacuum cleaner? And are they vacuuming my floors for me? But I'm still going to keep it open like this because I think it's very interesting to follow the behavior of this. And now that I've introduced you to the capabilities of the software and what it means, I can show you what a drone looks like. And notice that I've kept these things hidden. We've talked about the warfare aspect of this, the security aspect with the government. So I'm going to encourage everyone to not really talk about this much. This is the secret agent side of things. This could be dangerous ground for me if this information gets out that I'm tracking these kinds of things in my neighborhood. This huge quantity of drones, and it looks like it's like a drone railroad. It's like I described what I was seeing to a friend once, and they said, well, maybe it's like a railroad where they're being shipped in, modified, and being shipped out. Look at the characteristics that we see here. So first of all, they're all open networks, and some of these are seen for longer times than others. Some of these, the first scene and the last scene are the same number. So it was like it's 0 time that it was actually connected. The ones I'm showing here have been seen a little bit longer than that. But I'm covering up the MAC address because that would go to a specific unit. There might be someone somewhere in Little Rock that does not want me looking at these things. And if they track it by the MAC address, they may know that I'm looking. Also, the ID, I'm also covering that up. So let's be very careful as we proceed with this.
So essentially, you're saying with the right antenna and the know-how and the software and the equipment, you can really this is the information you can start monitoring in your environment.
Yes. Mm-hmm. Yeah, and it could very well be some information that people don't want monitored in my neighborhood.
Right, and there may be things that you can do data science-wise with the monitoring that maybe people didn't anticipate.
Yes.
Yeah.
Exactly. Okay, and so here we've got, notice that you can't really read the data here. What I'm doing is I'm just showing you that there are 40 of these. Since I've started collecting, I've got 40 of them. And now what I've done is I wrote a little program to sort things out just a little bit. Notice that I've got a count of 8 on top. This is one that has come back 8 different days throughout the time that I started monitoring and till just a couple days ago. It's shown up 8 times. And look, the next one in line, 6 times, another 6, and then it quickly goes down to 2 and then 1. So all the rest of these mostly are one-time seen. Like it came in, got modified, and went out the door. Now this is especially concerning to me. This is the one I really want to keep secret. So let's not share this one too much. Notice that I'm showing you both the ID and the MAC address, which could trace it back to a specific piece of hardware. But the only way I could really explain this was to show you the MAC address and the ID. So a MAC address should be a very unique identifier for one piece of hardware. So no other hardware should have this MAC address. And the drone ID should also be unique. We should only have one drone with one ID. But look what's happening here. We've got a drone that's shown up twice with this drone ID and this MAC address. But wait a minute. This ID also showed up with this same MAC address and this one with the same MAC address. So what's going on here? It's a little dodgy here, what's happening. It looks like they've got one drone here, but they've used it for 3 different drone IDs. So how do you track these things if in fact they are maybe swapping IDs around? And ideally, legally, I'm not sure that that's kosher. I think the idea is that you should tag your drone and not be swapping IDs around. So here especially, let's just sort of forget you saw this. Which brings me to the demo. I'm going to do a little demo here. So if you can put the camera on.
I'm going to be your camera person.
Yeah, we're going to set up the camera here and do a little hardware demo for you.
And this might be helpful, Phil. I just moved things around just a little bit.
Okay, sure.
Just so that you can look behind you.
Yes.
And see.
Good. Okay, so let me start off here. Let me check some things. I was also, if anyone was in the room, I was going to have them look at this particular device right here. If you were actually in classroom, I would have asked you to look at the Wi-Fi signals and see how many Wi-Fi access points you have, because this one actually sets up. Oh, I didn't get that turned up, did I? I meant to turn that off. Okay. Set that back to 0. Good. Okay, turn that off. So now what we've got here is we've got these little devices, and we can actually attach these to a Wi-Fi access point.
1 second, Phil. Let me
Sure.
get you.
Go ahead.
All right.
And
Okay,
what's
you're good.
unique about this particular device right here is that this one is programmed specifically to make its own Wi-Fi access point. And I use this device right here for a situation where I'm running a particular Raspberry Pi and it's continuously collecting data, but it's not connected to a monitor or a keyboard, so there's no way to do a smooth shutdown of the device. So how do I do a proper shutdown on a Raspberry Pi without a monitor, without a keyboard? What I do is because the device is actively looking for Wi-Fi access points, I power this unit up. It produces a Wi-Fi access point, which I don't use. It's just the idea that when it comes up, it has a specific name, and my software is going through, and when it finds this name, it will then do a proper shutdown procedure. So that's how I use this one. It's quite unique to think about a device this small that could actually be a Wi-Fi access point, and you could connect to it and collect data on that.
And I was going to say, in terms of your view, the camera's on the back wall.
Okay.
So you can almost pretend that there's a student
I see.
on the back wall.
Okay. Let me do a quick test here and see if I've got things running. Yes, I do. All right, notice that the light came on. Can you get it focused on the light?
Yeah, okay, I'm going to
Yeah, let me go
screen
ahead and
down. Okay. Oh, sorry. There, we've got a good view of the lamp here.
Okay. So what I'm doing is I'm turning it off. I'm using my phone to turn this on and off. I've got a Raspberry Pi Pico connected to this relay, and just as we can turn on an LED, we can also trigger this this relay. So let me just go ahead and turn it on, and you might even hear the relay click, and then I set it to low, and I can turn it off. So I'm actually using my phone here, which is on the IoT network, to access this device, which is on the IoT network.
I'll pan out just a little bit so they can see the see you working your phone.
So here I am going to turn it on, my phone, and then I'll turn it off with the phone. Okay, and I want to show you another thing with the browser. So I've got, let me bring this one, can I bring this one over here? Yep,
Sure,
yep.
sure.
Okay.
Here, we'll switch around here. So
Okay.
I'll move this over here.
Or if you like, you can put it back, because I'll Oh, yeah, that works just fine. Yeah. Okay.
Just, oh, and
Sure,
here,
sure.
let me again share the
There you go.
application.
Yes.
And entire screen, there we go. Are ready?
Okay, and watch my time too. Let me know if I get short on time.
Oh, no, you've got as much time as you need. You've
Good,
got about
very
another half an hour.
Excellent. Okay. So what I also want to do is show you what I've done with this device. And this is something that I was teaching in my IoT class. And what we've got here is the Raspberry Pi Pico, this very inexpensive device, and it's attached to the IoT network. And I call this the splash page because what it does, it's just a little bit of HTML, and it shows me the syntax that I can use to access this. And I can also do it this way. So let me just see if I can capture this part right here and add it to the URL. Okay. And let me just bring up the size of that one. So in this case, there's no HTML. I think you can see it. What I've done is bring the font up a little higher. I call the HTML side more the splash page to give you the syntax. And I don't really intend to use this in a browser. It's just that the browser is a very convenient way to demonstrate the capabilities of this. Notice that I was actually accessing this on my phone, and I was actually doing it through a command line. But I want to show you that we can also do this both in the browser or through the command line. What I'm really producing here is an API, an application interface that can be used not through the browser, but by another program to drive the data collection. And what I'm looking at here is essentially the temperature in centigrade and the humidity. I've got a device on here that is measuring temperature and humidity. So if I put my hand on this device for just a little bit and return and refresh the page, it's going to be much warmer. So I'll just do a refresh here with F5, and notice the temperature and humidity went up. And now if I continue to refresh, it will go down. Look at that, the temperature and humidity is dropping quickly since I took my finger off of that. Okay, and there may be, and so we'll probably leave it at that, but you can imagine that it's essentially more of an API to run through a script than it is to run in the browser, but the browser works nicely for demonstration. Okay, and so I think that pretty much covers the demo part of it, and we'll move on to any questions at this point on the demo or in the previous information before we move on to more the dashboard side of things.
Right.
I have a question about
Yes.
your the first part when you're talking about the 40 drone IDs. So
Yes.
it is a part of a project that you have with the government, I guess, to kind of monitor a certain bubble, a certain area for drones that may be going in and out and some that may be suspicious. Is that the objective of that you use all that equipment and those antennas for? Did I get this right? Am I missing something?
So the objective here is that this is my hobby. And so what happens sometimes with hobbies is they become your job. And so now I'm being paid to talk about this. So really it is, I'm also a gardener, so I don't spend all my time on the computer doing things like this. But on a rainy day like today, or a rainy weekend more when I'm at home and can't work in the garden, I like to explore my IoT world. This is just one fascinating area of my IoT world that I'm starting to look at.
And I should mention here that here, let me just get a few more things in there we go, in the frame here. Yeah, the Dr. Phil Williams is sort of our resident IoT practitioner, and he's done a number of projects in terms of, let's see, with hydroponics. He's worked with Heifer. He's worked with a number of folks who have wanted to experiment with putting, sensors to detect moisture and to be able to monitor that remotely. We've had there's a number of interesting projects. I can remember at one point over at the Clinton Center, they had, if you will, sort of they had their little Clinton Center island, and they were very curious about putting out sensors and various things to learn what's going on in the environment. So yeah, so Dr. Phil Williams has put up a number. Oh, he's worked with undergraduates who experimented with in the trucking industry, putting sensors in the back of the cab, because there are situations where a truck can be transporting ice cream, and they don't realize that the air conditioning has gone out. So they get to their destination and the ice cream is, a complete loss. And this is where, if you had a sensor in your cab that was monitoring the temperature, it could alert the driver, hey, lost power, lost the air conditioning. It gives an opportunity to really preserve and save what's being transported.
Product loss was a huge area in the trucking industry. Another thing I was interested in for trucking was shredding tires. They have huge liability in terms of damage because of tires shredding and coming apart in the highway, causing accidents. I wonder if there are ways to monitor that, like the vibrations or sound. So that'd be another area where very inexpensive microcontrollers could save significant money or even save lives if you consider the issues of shredding tires and accidents.
But it's very interesting because you can see that you can look at the IoT from several different perspectives. So you can look at it from the perspective that I'm the drone operator, and my drone is an IoT device that I'm using to collect information or to do stuff. And then on the reverse side, you can have folks on the ground saying, I wonder how many drones are in my environment, and what are they doing? This is are there any unwanted drones or suspicious drones? I mean, we don't really think about that today because drone technology is so relatively new. We think of it more as something that a hobbyist does, that the military makes use of drones. You have hobbyists. You think of, maybe FEMA using drones to do surveillance for, emergency. So you can think of, or insurance company, making use of drones to check for roofs. So there's a lot of valid reasons that people might use a drone, but you can also use drones to spy on people, and you can misuse drones. And so this idea that maybe in the future, that gets to be an issue, that, just like the police have to set up speed traps, do you have to periodically set up drone traps to try to find malicious or problem drones? So for Dr. Phil Williams, this was just a curiosity, one to build a skill set on, here's a problem, how would I go about, if I wanted to know what kinds of drones were in my apartment complex? This was his data science project, but it's also ties into, things that he liked to do. So yeah, we got another question. Go ahead.
Yeah, and this is incredibly interesting, all of this work. So thank you for sharing this. I was trying to reach your IP address that you put online there, the 144.167.232.253 ATH20, and
Yes.
two different networks, and I'm not able to. Is it because?
Yeah, there's a reason for that.
Yes, tell me.
Yeah, the reason is that it's behind the firewall on campus, whereas unless you had VPN already set up, you would not have access to it. So I was actually more anticipating. I imagine this to have a full classroom of students, and I was going to do a demo right in front of students, and I was going to ask the students to access this and look at different things. But considering that it's such a rainy day, that there are no students in this classroom, so we're doing this all remotely. So some of the things that I'm showing don't translate quite as well remotely as they do in the classroom, like the demos that I'm doing.
Yeah. But
Well,
Hermes
thank you.
teaches cybersecurity
Oh, I
in
see.
one of the Florida school
Oh, I
districts.
see. Yes.
And so,
Mhm.
and
So,
I was
so I
going to
was
say,
fishing for that. I was fishing for that for the VPN. So
Okay, yeah,
yes,
that's where it is. So, and they used to have students, they give students VPN, but of course, now with security issues as they are, you have to fill out a form to get VPN for students.
yeah. But I was going to say, talking about getting students engaged in cybersecurity, cybersecurity can seem a little abstract, but when you combine it with IoT, because you notice, mentioned Dr. Phil Williams was concerned that somebody had taken over his robot, his vacuum robot. That is something, if you kind of show, I don't know, it's kind of dangerous. As Dr. Phil Williams says, if you show students, well, here's how a hacker can take over a robot on an open network and, have it, come after people, but for students, it might be a great way within an environment, for them to actually see, oh, I got access to this device and now I'm able to control this device and I'm now making it move around the room. That can really kind of drive home, maybe in a more tangible way than simply, I'm hacking into a network.
Yes, there's more cybersecurity to come. I have to sort of pass through some discussion of the dashboard. Depending on how much time we have, we may get to some more cybersecurity discussion, specifically on people using very weak passkeys. So stay tuned for that, depending on our time.
Yeah, so I'll let us know if you have more questions, but I'll let Dr. Williams continue.
Okay. Can we move that one out of the way?
Yes.
Sort of bring it back where it was. Thank you for helping with
Sure,
that.
yes.
I'll let you do it since you're better at that than I am.
Yeah.
Very good. Okay.
But I think, IoT, if you're trying to demonstrate to students, I was going to say security, privacy, as well as basic hardware networking principles, it's a great way to make it very tangible because the IoT stuff is things that they can physically touch and pick up and see it in action.
And fairly inexpensive as well. And this is sort of the challenge we had in bioinformatics. You can imagine bioinformatics is very abstract, both the concept of differential gene expression or the big servers tucked away in a server room.
You can't really see DNA.
Yeah, you can't see DNA and you can't see the servers. But with IoT, you can hold these in your hand and you can measure temperature and humidity, and everybody can grasp that and do some Python programming to reveal those things and then layer on more abstract things after that. So I think the IoT is a great way to introduce programming to students. So now let me know if there are more questions, and I'll go ahead and so this is my dashboard at home. It's up on a mantle, and I started out very simple kinds of things in the dashboard and moved on to more complex things. Let me just go ahead and move right on then. Well, I guess I should talk about that it's essentially just a simple bash script that drives the Chrome browser. So it loads up a page. This is a simple HTML page. It's a static HTML page that's dynamically created and displayed. So a script builds the static page. So they're only displayed for 5 minutes, and then, which sounds short, but it's plenty of time to enjoy that page before the next one comes up. And here's kind of a zoom in on one of my earliest dashboard devices. You see, here is my robot that I've been tracking from the very beginning. Also notice that there is a game room speaker. It's an open network. This is how I found drones. I'm interested in open networks. So I look at all these open networks and see what comes around. And what came around was drones. Notice also I've got the EXX, so you can't see exactly where this one is, but it's a public one in the apartment building. And notice that I've got the count of things that have attached to that. So there's not a lot going on for this page. It's still early in the day for this one, but more data would come in through the day. 3 devices attached to that open network. Now here is the one that I talked about earlier. This is an Apple product, and I never really understood what it was but now I have a better handle. It's likely an Apple earbud. And what happens with this particular device here is this one will leak the random MAC addresses that come next to it. So it's a really nice little way of crowdsourcing the population movement. Notice that it's so early in the day, this has a count of 0. This count could really go up as the day progresses. As people walk through the building, it starts to register these devices and give up the random MAC, which you can't, of course, track, but you get an accounting of how much movement is going on in this building. And also, I added this fairly recently. I call it transient networks. These are just networks where you don't know what they are, but they come and they go. And here again, the number is small, but over time, it builds up over throughout the day. And I actually have a particular web page that I use, a static HTML that comes up that shows me if a lot of people suddenly come into the building, it will give an indication that there's a large movement of people. And here specifically, one device that I use to track the drones. There's no drone shown up here, but again, we have these open networks, and the MAC address here resolves to some IoT lighting device. And here, this one's called Ring Setup. It's likely a doorbell.
Wow.
So people are buying products, they're powering them up, but they're not necessarily attaching them to their Wi-Fi network. They're sitting here with an open network that can be discovered. So it's like a way of seeing things pass by. Eventually these will go away, new ones will come in, and you can see the specific device that I use to track these two. Notice that this one is Unit 1, Northwest. I live in a small apartment, so there's very little difference between the Northwest and the Southwest here. It's smaller than this room. And yet look at the difference in what it's seeing. On the Northwest, it sees the lighting, and the Southwest, it sees the doorbell. And here, I was given a phone to do the Android IoT work. This was given to me by a professor at Harding University. And what I did was to just decide that I wanted to make what I call your basic IoT platform of an Android phone. In other words, we want to get all the sensors and display everything we can in one place, and then we know what it's doing, and we can decide what we want to layer on top of that. So this is your basic foundation of an IoT device of the Samsung phone. Notice we've got the date, the time. This is current data from just a few days ago. Notice the battery status is good, and that's the string that comes out of the phone. I'm not making this up myself. This is the data that's from the phone. My assumption is when that battery is no longer good, it will no longer say good. It will say something else. Also, unplugged. This is the plug status. This one changes when I plug it in. When I plug it in, it does not say unplugged. It tells me that it's plugged in. The battery level. Notice that we've got 70% battery here all the way until 8:30 on that day. And then it jumped down to 64% on that battery. Look at the battery temperature. From 1:30 in the morning to 8 o'clock in the morning, that battery temperature was steady at 23.8 C. And then 8:30, that temperature jumped up to 24.9 C. Notice also the discharge on it. So notice we've got a -92,000 all the way through until 8:30. And then the battery discharge jumped to more discharge. And that coincides with the temperature and the battery going down significantly. That brings us to X, Y, and Z. This is the accelerometers on this phone. So this phone is fixed in a window looking at the courtyard, and it actually takes a picture every so often as well, but I'm not showing the pictures here. Notice that we got a little noise on the X at 0.02, 0.00, and back again, we've got a 0.03. So it's got a little noise sitting here, pressed against a window, and a little bit of noise in the accelerometer,
Vibrations, yeah.
as you would expect. I wonder what it's like when we get a big thunderstorm, how much that
Yeah.
rattles the window. But of course, it's only collecting data every 30 minutes. So it's not continuous, or that would probably run down the battery quite a bit. Notice we've got the Y and the Z, also a little bit of noise in that. That brings us to the last column, the light level. Notice that from 1:30 down to 6:30, the light level was 0. And then at 7 o'clock in the morning, the light level was 17 and goes up from there. And when the light level is above 0, it takes pictures. And if the accelerometer indicates that it's in this orientation, it will take a picture. If it's not in this orientation, it does not take a picture. If I take it out of the window and charge it, it does not take a picture. So the script is built in a way that collects data and processes data in specific ways. And here is the battery status. This is a Python script that uses matplot, and it will update this plot and show this plot on the dashboard. And here again, very steady at 70%, and then 8:30 it drops down. How are we doing for time?
We are doing, yeah, 10 minutes.
10 minutes. Okay, I'm going to go through pretty quickly here. This one has to do with cybersecurity in the cloud server. So we have a cloud server, and in the cloud server, what I do is install fail to ban. What fail to ban does is it looks at the Apache logs, and when it sees that there's a bot attacking multiple times, all those failed attacks cause it to get banned. So it's called a jail. So the IP address of this attacking bot is banned, and it can no longer attack because its IP has been banned from this web server. So what I'm doing is I'm looking at the count over time. I'm banning these IPs for 40 days. I talked to one guy, he bans them for a year. Maybe I should ban for a year instead of 40 days. What happens then is after 40 days, the IP comes back out. So what we're looking at is the count of banned IPs. And if they go in, we get a positive number. If they come out, it's negative. So it should hover, if everything is steady, it hovers around 0. Just as many IPs are coming in as going out. So you can see at the beginning, there are more going in, and then later on, there are more coming out. And as long as it's steady around 0, everything is fine. If I see this bump up, I know there is a significant attack going on, and I may want to look at the server more closely and see if I can do more to avoid these kinds of attacks. So it's a dashboard. I sit back, I can see this from the kitchen, I can see this from where I use my laptop. I just glance up and see what's going on in my world. And of course, this is yesterday. This is what the weather map looked like yesterday. It's similar to today. This is current events. So one of the things that comes up in the dashboard is the weather. And I call this art. It's green and red and orange.
Yeah.
It's the weather, but it's also, you know, art in motion kind of thing. So now we can talk about art. The art of data science. So not only do I want to have information come up, but I also want to have enjoyment of art. And this is my enjoyment of art. I actually, many years ago, using DOS5, I think there are probably very few people here that have used DOS5. And I actually produced the data I'm going to show you using DOS5 quite some years back. The application was Fractent. And you can see that even currently, the data for Fractent is over 5 years old. But I wanted to show you that it's still a going thing, and it's used to produce images. And for this particular talk, I decided I would gather up some images and make a slide. So this is the first time I've ever viewed all these images in this kind of environment. And it's quite a bit of color here. And this is just a small sampling of what I've got. I didn't get the full count, but there are many, many, many images that were produced using Fractent. And when I got this particular application, it came with what we call parameter files, which you can think of as a recipe to produce these images. So I'm not the artist here. I'm the guy that did the data science to render the images. So I don't own these. But I rendered some very interesting images. Back in February, I was snow skiing in New Mexico, and including Taos Ski Valley. Taos, New Mexico is known for art, including the art of Native Americans. And here the colors remind me of that kind of art. I would call this the warrior's shield. And here is another one we might call the warrior's shield, which has a nice Native American Southwest feel to it. And it's just a recipe to build fractals. This one also, notice these tendrils that come out right here. If you've ever flown over the Southwest and looked out the window, you see these kind of tendrils in the washouts of the arroyos. They're very fractal-like. So here we might call this, but it also looks like fungus growing. So we may call this one arrayo fungus. And now we can shift into something a little different. I call this space helmet. And I call this surfing the fractal wave. And I call this one the cost of gold. And now we can move on to a different type of art. This is art produced in another type of data science. In bioinformatics, we have different kinds of file formats. This file format is PDB, Protein Data Bank. And essentially, this kind of data is used for many different things, including molecular dynamic simulations, which relates to drug discovery. And here we've got, these are text files, and each line is a record that describes the 3D structures that I'm going to show you. And so here is something that was, this data was actually proprietary. It was submitted to a system to do particular data processing on the PDB file, but that PDB file is really proprietary. We would not show that file. That's their science and exclusive to them. But we can maybe render this into a piece of art. So this, again, is one random piece of art. Just like the fractals will come up randomly. So when that page comes around, it will have a different piece of random fractal art. And in this one, it's a different piece of PDB art.
Can you tell the students a little bit about what protein is being rendered here?
I cannot, because it's actually proprietary. This is actually for company data processing.
Okay.
So it's data that's been put on the server, proprietary, but I'm saying I can just make an image of it. But again, this might be considered something we don't want to pass along too much.
But could you tell them a little bit, though, that what they're looking at is a depiction of a protein? Yeah, it's a depiction of a protein, and I see where you're going here. And this protein is likely an enzyme, and this enzyme may have a pocket for a particular metabolite, and it may be a druggable pocket. So they may be trying to study how the drug and the enzyme interact in order to move forward with possibly a cure for some disease. So yeah, thanks for getting more detail on that. Because like normally, we just, you have all these cellular functions, and it's like, so how does your cell, how do we live? What makes life possible? And basically what you're seeing is basically, that rendering is what you could potentially see if you could actually go down to the almost atomic level.
At the molecular level. It's sort of a piece of art that describes, for me it's art, for them it's actually part of the science to understand the enzyme and how they can make it into, find a drug to then access that pocket. How are we doing on time?
And let me see how we're doing here. Oh, 2 more minutes.
2 more minutes. Okay, I'll move on. We're coming close to the end here. I can move very quickly. So what I showed you was the more viewable dashboard on the mantle that I can enjoy sitting back, working my computer. I can just glance up and enjoy the fractals. or the art of the proteins, or my other kinds of things that I'm interested in. Here is my original dashboard. It's nothing more than a set of LEDs. So let me explain what the LEDs do. So the blue one tells me that my Raspberry Pi has dropped off the network. And so I want to be sure that it gets back on the network. So it's very simple. The yellow one is a deauthentication of a client from my AP, from my access point. So what that means is someone could be actually trying to kick me off the network so that I reconnect, and they could capture my encrypted passkey and then use that to try and get my passkey from that. So I want to know if I'm actively being attacked. And this came on a few times because normally when I go to work, my phone gets deauthenticated. And if the number gets a little higher than normal, it turns this on. So all I did was just raise the threshold, and this light stays off if I leave home and will now only come on if I'm under attack. The red one is the phone on the network or not. When I come home, it will be on. And when I'm at home for a while, it will go back off. The green one is normal deauthentication behavior. I mentioned that when I go home, go to work, then the router will deauthenticate, and this happens all the time. People are coming and going. So it shows me the natural flow of deauthentication going on in my environment. A simple dashboard of lights. Here now we get into some cybersecurity. What I can do is I can passively capture these passkeys. And I can then take these passkeys and I can run them past a dictionary. And not only a dictionary, but we can also have some rule sets that add to the dictionary. So what's happening here is that people are taking what is normally a very secure passkey and they're making it insecure. So people at home, don't do this. Don't take your secure passkey and change it for something like what they're doing here. Look at what they've done for a passkey. Arkansan, that's a dictionary word. That's just too easy to recover that password. Don't do that. Wine girls, okay, that's a little more challenging, but we had the ability to capture that. Keep one secret, apparently not. And here, notice that I'm hiding some of the access points names here, but I'll go ahead and tell you what this one is for associated with Tiger. The CE is for central, as in central high. And if you know the mascot for central high, okay, there it is right there. But look at what the next one does. 2014, 2013. That's only 8 characters of numbers. That's just too easy to recover. Don't do that. Raven, okay, that's a little more challenging, but it was done. And the 8 characters of 1 through 8, don't do that. And notice I've got it X'd out here. I was trying to find the actual device that used that one. It may have been an iPhone, and those sort of get lost in the shuffle. So I didn't have time to sort out specifically, show you that. But believe me, people are using weak passkeys as bad as 8 characters, all numbers. A friend of mine got his optic fiber put into his new home, and the first thing he did was change it to home sweet home and 4-digit number. And I said, don't do that, change it back. He did. And it's a good thing that he did, because in today's environment, he could get hacked way too easily. And that brings me yeah, good advice. You're welcome.
Yes.
And I can wrap it up real quickly now. These are some students that I work with on IoT projects. We had a camera on the bubbling goo. It's not so gooey here in this one. It's fairly clear, but this is a cyanobacteria project. And here with Caitlin Simmons, this is where she had a brand new Raspberry Pi with 2 camera ports. And so we used those 2 camera ports to put the camera underneath the grating, pointing right up through the grate underneath the Erlenmeyer flask of cyanobacteria. And we have images of cyanobacteria in her experiment. So that wraps it up, almost on time.
Yeah, very good.
All right, thank you.
Any questions? We got a minute or two for questions. very good. Let me see if we have any, okay. Well, I hope folks, and this is kind of, as they say, we've been talking about, IoT, and I think we'll, Dr. Dactus, I'm going to check him. I think next week he's going to talk a little bit more about IoT. But I think this will give you an idea why we're talking so much about IoT. If you're into cybersecurity, I think the IoT is going to be a huge area. Think about, just all the wearable devices, everything that we have flying in the air, going through our pipes, who knows? Coming up with interesting IoT applications is an area, and analyzing the IoT data is an area. So between the cybersecurity, the computing sciences, the data sciences, the ethics, the law, the management, the governance, this is an area that there's going to be a host of different careers across professions. And so it's just something to look at, as you're thinking about, where will I go in the future? Where will jobs be? This is a good area to think about.
Yes, a growing field, certainly.
Yeah.